Hello, my name is Enrique Espinosa. We are learning how to program classes and objects in the C# programming language. This is the third video in the series. It's our turn to review the concept of encapsulation. Encapsulation is a concept that is key in object-oriented programming. Recall we already learned how to make an instance of a class that is an object. For that reason, we know that this object has a very well-defined structure. That is, two sections, attributes and methods. Now, encapsulation means that attributes and methods are hidden from the outside world. That is, they are behind walls. These are the walls, the boundaries of the object itself. So, the theory says that nobody on the outside world should be able to touch the attributes without permission. Permission means that the only way to change or read the value of an attribute will be by using an interface. That interface will be any of the authorized and predefined methods, or else called behavior of the object. So only methods are allowed to change or read attributes. Nobody in the outside world is allowed to do so. For example, this one object might want to access or send a message to change or read any attribute inside another object. If this object wants to do that, it must search for a method in the target object and run it. When object number 1 runs a method in object number 2, we say that object number 1 has made a method call to object number 2, or else it has sent a message to object number 2. For example, this object is called instrument. So it's a piano, a cello, etc. Now, in the template class, we already predefined there exists a method called setName. So somebody on the outside world can fetch that method, run it, and thus allow a parameter to be passed over to the object. And the purpose of doing this is to change an attribute inside the instrument, for example, the name, thus effectively changing the name of the instrument from the outside world. So once again, we are using a method. That method is behavior. Now this behavior becomes the interface by which somebody on the outside can read or write attributes inside the object. In code, this looks as follows. First we write the name of the object, which is instrument of course, then we write a dot, that is we're about to call a method, and then we write the name of the method and parameters if they need it. This is called message passing, or else calling a method on the target object. Now it's okay for somebody to use an interface as we said, but look at this other example. Somebody's trying to directly access the price attribute inside the object. And somebody's trying to make it -99 without using or calling or sending a message. Somebody wants to do it directly, thus breaking the walls. We must not allow this to happen at all. Somebody might be trying to do this. Use the ID of the object and then dot and then use the name of the attribute directly and changing its value. Price is not a method, it's the name of the attribute, so it's somebody's trying to directly access the attribute. This is not permitted, it's forbidden. For that purpose we need to resort to a couple of conventions and standards. In industry, the Java Beans, Enterprise Beans API introduced the notions of getters and setters. This has been used by the .NET community and others as well. So what do we mean by getters and setters? Well, first recall we might have a certain attribute, let's say price, which is of type float. Now for each attribute we will have to write two methods. One will be a getter, another one will be a setter. The purpose of the getter is to extract a copy of the value of attribute price and give it to the public. The purpose of the setter method is to allow the public to send a new value to be stored in the price attribute, thus replacing the previous value. So getter is to read, setter is to write. Now both methods need to be public. That is, although they reside inside an object, they can be called from the outside. They are like a door or a window from the inside to the outside. Now, in the case of the getter, the convention for writing the method is very, very strict. We must begin by writing the get prefix. Notice that the word get is written in lowercase letters. Next, we append the name of the attribute, but we change the first letter from a lowercase to an uppercase, and we get a compound name, get price. In the case of the setter, we start by writing set, lowercase, and append the name of the attribute with an uppercase first letter. This is a strict convention. It must be done like this. No other name is allowed. Now, the getter receives no parameters, while the setter will receive one parameter. This parameter will correspond to the new value we want to store inside the attributes. The reason for which the getter receives no parameters is because there's no question involved. This method will just copy the name of the attribute and return it as a type, in this case float, but nothing should be said, nothing additional is required. Now, the actual signatures of getters and setters start by having this header. The header is a public float get attribute name, public void set attribute name with one parameter of the same type as the attribute. The names of the methods are in what we call camel notation. Why? Because the first word is always lowercase. From the second word on, we begin with an uppercase letter. We can append more words if we wish, but each one of them must start with an uppercase letter. So giving the impression of a first letter bump, second word first letter bump, like a camel hump. So, in the case of the getter, the signature continues as follows. We open the method using round brackets. The only thing the getter will do is to return the actual value of the attribute, but we tend to write this keyword this. So what does that mean? Well, recall that this is the object we are working with, right? So we're sending a message to this gray object, but there might be other clones, other copies of the same class, right? So in practice, we have one price, another price, a third price, and there shouldn't be any question as to which one is the one we're talking about. So when we append the keyword this, we mean the local copy. We are sending a message to this one object, so please access the local copy inside this one object. Don't try to do it in any of the other ones. That's what this copy, this local means. The same goes for the setter. The method just has one line. The line receives the parameter and assigns it to the price attribute, and we append the keyword this for the same reason. We want to change just the attribute in the local copy, the local object. So this object, not this one, neither this one. Thanks for watching.